So at this point, we have some open time for discussion. This is discussion over any of the previous talks or related subjects, if anyone wants to quiz an expert in the room. I can actually go ahead and start. Bill Patterson put in a question for Fatima in the chat. So Fatima, Bill asks, and I believe this is, are you aware of predictions for solar cycle 25 duration as well as the timing of the peak? And could you comment on that based on your predictive studies?
Yes. There are predictions, several predictions that are all over the map. But we've had the Solar Cycle 25 prediction panel, and they actually I guess it was almost 2 years ago now. Wow, time flies. So yeah, they predicted Cycle 25 to be comparable to Cycle 24, and I guess I should look for the exact amounts and values, but I guess their prediction was like the maximum would be in the year 2024. And they expected cycle 24 to end in 2020. So based on their prediction, we are already in the cycle 25, which I guess we are. That's their prediction. So they predicted somewhere around, I should look for the exact values, but they expected it to be comparable to cycle 24. So based on that, our results are in line with what they got.
Yeah, I'm curious because I know that the sunspots for cycle 25 have shown up, and that's true. I'm wondering if perhaps you know if even the very beginning part of solar cycle 25 matches any of the predictions. It's obviously very early, but could you comment on whether the first year or so of solar cycle 25 is playing out as we might think?
I think Jody is actually following the sunspots much closer than I do, but it seems like the increase isn't like very sharp. So it seems like from what we see now, we probably won't have like a sharp increase or ending to in a strong peak.
Sure. Well, I happen to know that one of my colleagues works on MAVEN, and they were alerted to a big space weather event that I think is going to strike Mars either today or tomorrow. So it is true, the sun is waking up, which is nice to see. Hopefully there's some more interesting science. So yeah, so we are otherwise generally open for any discussion or questions. I think the best way is if people drop questions in the group chat and you put a little Q, and if it's for a particular speaker, you can identify them. But feel free to take a minute or so and brainstorm clever questions to any of the colleagues that are here in the virtual room.
Indeed, Andrew, you have a question in the chat window from Shaosui earlier.
Sorry. Yeah. If I could just say a quick sentence. So their prediction was sunspot numbers between 95 to 130 sunspot numbers. And from what I know from Jody is based on his correlation, next cycle would be around 100. And based on like the latest observed sunspot numbers, the next peak would be like 140 sunspot numbers. So we see a very close match between.
Okay, well, time will tell in the next few years. It'll be exciting to watch. So, sorry, Daru, you said I had a question?
Sure, yeah, it's from Shaosui about what causes the downturn in the fractionation curve at about 1 microtesla.
Right. So to recall a plot that was 8 talks ago, one of the things I was showing was the ratios between argon and krypton and xenon that were implanted in the solar wind. And it was true that those curves were not perfectly declining or perfectly increasing. There were some odd bumps. The interesting reasons behind this are actually a couple-fold. One is that These ratios, obviously you're dividing one thing by another thing, and each of those ions have different charge to mass ratios. So argon has a little bit higher charge to mass ratio because it's a lighter species than krypton is. And what that means is that those two ions are sort of interacting with the different strength paleomagnetic fields in different ways. What we generally see in the model is that for very low paleomagnetic field strengths, we saw that the heaviest ions can basically just penetrate right through the bow shock right down to the surface, whereas the lighter ions were sort of diverted around. What we noticed after that, however, was once you got to a critical strength that I think was around, I think it was 500 nanotesla or a microtesla for the magnetic field strength, that nearly all the ions were shielded from sort of direct precipitation onto the day side of the moon. And what started to happen was the cusp precipitation became much more important, as well as particles that had been trapped sort of in a radiation belt-like region, a quasi-trapped region, and then were sort of slowly grazing across the surface of the moon all the way around. And the reason of these sort of somewhat hard to understand bumps in the fractionation curves is because these different effects, the direct precipitation or the cusp precipitation or the radiation belt precipitation, those all sort of appear at different magnetic field strengths for different ion species. And so the argon curve is doing one thing as a function of magnetic field, and the krypton is maybe slightly offset. So if I'm taking ratios of them, the ratio can actually go to fairly high values and then go to fairly low values because the underlying ion behavior is actually somewhat complex and due to a number of different features. We actually ran, I think it was 8 paleomagnetic field strengths and 9 ions. So I have this giant chart of all the different types of interactions. And it is somewhat difficult to summarize in a single curve. There is actually a lot of dynamics going on beneath the surface. So it is obviously dependent on the paleomagnetic field strength and the direction that we choose for the paleopole. And a lot of this has to sort of be further explored, but it does at the end of the day, I think, point to the fact that these interactions are actually fairly complex and is definitely something that needs to be taken into account when we're trying to interpret this sort of lunar soil sample record. So,
yeah, thank you. Yeah. I have a follow-on question. If you pull up your plot, that'll be easier to describe. And I can state, I was wondering, what is your numerical solver? Is that electrostatic with a B field or purely electromagnetic?
This is it's a 3-dimensional electromagnetic hybrid model. So the way it works is that we follow individual ions as macroparticles, sort of similar to the particle and cell method, or actually it's identical to the particle and cell method for the ions. The electrons are considered to be a fluid. So what that limits you is that you have to work inside of a regime where the physics that you're interested in is greater than the electron inertial length scales, but typically smaller than the ion inertial length scales. And it turns out that the moon's paleomagnetosphere, and actually the moon's interaction, even without a paleomagnetosphere, is right in this sweet spot where the scalings are larger than the electrons scalings, but smaller than typical ion scalings. And so the hybrid model has been well tested. It was developed by my colleague Shahab Fatemi, who's now in Sweden. And we've applied it to Mercury, the moon, asteroids, all kinds of things. And so it does solve electromagnetically. It is self-consistent in that sense for the fields. And it actually has a lot of power and a lot of ability to describe a lot of these. It, for example, does not have the ability to describe something as large as the Earth's magnetosphere. That is really somewhere where you need an MHD model because you're looking at far larger than ion scale. You can do it with a hybrid. It'll just take a really, really, really long time to process.
So it's a kinetic ion, fluid electron, electromagnetic.
Correct, absolutely.
And how did you initialize the dynamo within the moon? Just a magnetic dipole?
Yep, just a simple magnetic dipole. We typically oriented it such that it's aligned with the spin axis of the moon. It doesn't necessarily have to be that way, but to run the first set of simulations, that's sort of the default assumption. There is some laboratory measurements of what's called the paleopole orientation. So was the pole perfectly aligned with the spin? Was it offset? in which case it would sort of rotate around on a lunar day.
Mhm.
Those are all possibilities, and they are deserving of more research and more modeling to try and understand what the effect of that would be on these isotopic precipitation ratios. So.
Yeah, for all the charts you presented, they have the same orientation or inclination of the dipole.
Yeah, this is often the challenge with modeling, especially somewhere where you don't necessarily have a lot of constraints, is you can explore a lot of phase space, but you have to pick something small and manageable to get started.
Right.
Yeah.
Yeah. Thanks. Thank you, Andrew. Very interesting.
So yeah, again, I'd encourage folks, if you have questions, to drop them in the chat. I imagine we'll let it go in, let's say, another couple minutes, and if no new questions come up, I think we can release people to take a small break before going back to the plenary. But I do want to make sure everybody has a chance to quiz your colleagues as much as you wish. So
yeah. And some of our talks in this session are connected with the posters. So if you're interested, you can also go to the poster session, see the posters. Yeah. Maybe people are forming questions, and if not, we'll have a 15-minute break before the plenary.
Thank you all. Bye.
I think Daru, we can perhaps close the session here.
Yeah.
But I wanted to thank all of our speakers again, and everyone from multiple continents from calling in, bright and early or late in the evening. It's much appreciated that everybody can come together, and hopefully we can all see one another in person at some future date, hopefully not too far from now. But I think until then, it's wonderful to see everyone virtually and connect and learn about all kinds of good science. I encourage you all to stop by the posters with GatherTown. It's a neat experience to walk your little person around the poster hall and interact with people. So I encourage you to check it out. And other than that, Daru, I don't know if you have any other closing thoughts.
Yeah, I think it's good